Imagine this situation. You have just completed a beautiful piece of code. It is flexible, configurable, extensible, general. Oh, it is really wonderful. What's more natural than to start thinking that you could share it with others, make others start using that general piece of code you made. Then, on the second look, you understand that it's not really that much general, that much configurable. It's not even consistent. It has many flaws. What will you do? Will you give up? Or will you change your code, mold it into something that starts to look like a reusable library? In this video, I will show you the steps you need to make to create a reusable library out of a piece of code you made. This is where the story begins. You don't have to read this code. I have a bunch of code working with EF Core here. It's really not important. What is important is this line. It is a call into that reusable code I made. The thing is that I'm using EF Core in this demo and immutable entities, and EF Core doesn't work with immutable entities, so I patched it with this extension method, and now it suddenly works with immutable entities. It's wonderful. But it's not a library. Here I came up with this extension, which makes EF Core operate on immutable entities almost natively. But there's a lot of that code. It does everything. And it is all located in the DB context, precisely where it doesn't belong. Anyway, it is a good starting point. It is a proof of concept. It works. I want to turn it into a library. So this is where the story begins. I must pull that code out somewhere, and that somewhere will be a class library. And then right at the beginning comes the one hard thing. What do I call this? Could I call it Immutable Entity Framework Core? First, it's very long. No. Second, EF Core is not immutable. Entities are, so this name is also wrong. Maybe immutable.entity framework core. Oh, this looks nice, but it has another flaw. This makes me feel like I'm hijacking the entire immutable paradigm, which I'm really not doing. I have an idea. Immutable domain looks like a good candidate to me. It really is a domain, and it's truly immutable. Then it specializes to Entity Framework Core. Well, this name looks like a good candidate for me. Drum roll, I have created a library project. I'm adding dependencies. I'm adding the project to the solution, referencing it from the client project. Everything is there. I have just initialized the library, the reusable library. So the first step you will always have to make is to choose a name that is both descriptive, reasonably short, composed of multiple components if it must be detailed, like I think it has to be in my case, and then start moving your code there. So I have just pulled all the code from that extension method and everything it invokes into a public static extension class. And that is the moment when I realize that this code is really not that beautiful as I thought it was. Let me show you what I mean. First, I will include the library, so the extension method is now accessible. But then, here's the issue with how I'm using this extension. Adding an immutable entity applies to the invoices DB set that has nothing to do with my extension. But then updating the entity doesn't operate on invoices. No, it operates on the entire DB context. My beautiful library is not consistent to begin with. You cannot write reusable code which is not consistent. Nobody will understand what you wanted to say. Did you want to say work with DB sets? Did you want to say work with DB contexts? Not the same thing. So I must fix this inconsistency. Inconsistencies are a deadly sin for libraries. Back to the drawing table. You can fix most inconsistencies by introducing new concepts. For example, I might define a repository for immutable entities. It would bridge the gap between DB sets and DB contexts and operate on both behind the scenes. Wrap around a DB set for the find method, wrap around DB context for adding and removing, and then comes the critical point, updating the entity. That is that extension method which did everything. Simply invoke it behind the scenes, so nobody can see what I'm doing. I'm accessing both the DB set and the DB context, but that's not visible from the outside. This class has a consistent public interface. That is another important lesson. Invent concepts, give them names. Let the users refer to those concepts. And what stands behind is just your implementation. They won't even know it exists. More issues will surface over time. You don't have to read what I will do now. This code doesn't belong here. It belongs in the library. I will put it into an extension method, then get back to the DB context and look. Add freezing, that is the concept. Again, don't bother with the details. That's an implementation detail. But I gave it a name. The consumer, the DB context, which the user will write, will just have a call, this.add freezing. Now it suddenly makes sense. Then comes the moment when I will use that immutable entity repository class I made. Instead of the DB set, it will be this. Instead of picking the set, I will instantiate the immutable entity repository. Do you like the name? Which brings us to another important point in library design. Your library will be worthless if it doesn't produce short and tidy code. It's time to discover abstractions. So first, we had a concrete concept. Now we need an abstraction to hide that concrete concept away. But before inventing abstractions, let me remind you that this video and all videos on my channel are free thanks to the patrons. If you like what you have learned from this video, if you like my videos and my channel, then please consider joining the growing community of patrons on my Patreon page. You can find the link in the description. That will give you access to the source code from this video and all other videos on my channel. Thank you very much. Let's get to inventing abstractions. Everybody loves that. Here, an abstract repository which only has one generic type argument, not two, so it's automatically simpler. It exposes those 4 methods which you saw me use. The concrete implementation will only implement that interface, and then comes the cherry on top of the cake. The extensions, which I will expose to the users, and they will be a part of the documentation for this library, will include one convenient extension method that instantiates the immutable entity repository and returns it as the interface. This extension method effectively hides the concrete class from the caller, also hiding one additional generic type argument. Why would anybody bother with that? That's an implementation detail. I needed it. The callers don't need that. So let me show you what the calling end will look like, the DB context. It will return an interface. It is shorter and easier to understand. Returning classes is really inconvenient. You always think, oh, what baggage does this class carry with it? What else should I know? With interfaces, it's very easy. Just look at the methods and that's it. But the right-hand side will be much more interesting. Take the DB set of invoices and turn it into an immutable entity repository. Just call the extension method and forget all the concrete types. This will make your library much more easier to use. And if you remember other libraries for .NET, you will see that many of them are using this principle, so you should start using it as well. We have almost completed the new library. The last step is to pull all the specifics and put them into a nested namespace. This is what you see when you close the folder. The user would only see the types they should really care about. Everything else, possibly dozens of types, would be hidden in the nested folders. And this is the ultimate consumer. It would call add immutable async. Its name already tells the whole story. There will be no confusion about what this method does. Add on the DB set was not this clear when it comes to using immutable models. Call update immutable on the invoices repository again. So both methods apply to the repository, and the repository pattern now suddenly becomes obvious in this code. And my code is, I think, much better than it used to be. Think about these steps the next time you decide to write some reusable code.